Welcome back. In this section, we're going to be talking about triangles and their interior angles. So we're going to go ahead and get started. And then our interior angle theorem states that the sum of the measures of the interior angles of a triangle is 180 degrees. So let's break this apart. Sum means addition. Measures of the interior angles, so those are the angles on the inside, so 1, 2, and 3, that's equals 180 degrees. So basically what that means is the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 will equal 180 degrees. That's our basic setup. Whatever is here for angle 1, I plug in here. For angle 2, I plug in there. And for angle 3, I plug in there. And then solve for the unknown, whether that's an angle or whether that's x within an expression. It all depends. We'll be working with both. Now, if you're sitting there going, but how? Why? Well, we just talked about parallel lines cut by a transversal. So using that and this image here, by the image, I know that line, actually, I'm just going to shorten this up. That line T is parallel to segment BC. So that is given to us. And since that is true, then if these lines are parallel, then the alternate interior angles are congruent. Sorry, I had to piece words together. Then alternate interior angles are congruent. So what does that mean? That means that angle 4, or the measure of angle 4, is equal to the measure, go back, measure of angle 2, here's 4, so alternate interior, parallel, parallel, alternate inside would be there, and that measure, measure of angle 5, so looking at this one, is congruent to the measure of angle 3. So equal to the measure of angle 3. And knowing what we know about the inside of a triangle, or not the inside of the triangle, knowing what we know about straight angles and the fact that they are 180 degrees, then I know that the measure of angle 4 plus the measure of angle 1 plus the measure of angle 5, so angle 4 plus angle 1 plus angle 5 is going to equal 180 degrees. And that, again, because a straight angle is 180 degrees. Now, I'm going to use by substitution. So by substitution, then I know I can replace the measure of angle 4 with the measure of angle 2. So the measure of angle 2 plus, and then angle 1, we didn't have anything that replaced it, measure of angle 1. Plus, and then measure of angle 5 is equal to the measure of angle 3, so plus the measure of angle 3 equals 180 degrees. And so that is one of the proofs that they use to prove that the 3 inside angles of a triangle will always add up to 180 degrees. But really, this is what you need to know from this slide. Woo, as I cross through everything else. This expression, oh my goodness, forget the box. This expression right here, that's what we need to know. This just tells you, gives you a reason why that works. This is what you need to know, and let's use it. Find the measure of the missing angle. So we're going to call this x. I don't know if you can barely see the 1 on your paper. I know that much. So I know that 32 plus 43 plus x equals 180 degrees. So now I'm going to combine like terms. So I'm going to get x plus, and then 32 plus 43 is 75 equals 180. And then to solve for x, I'm going to subtract 75 from both sides. So then x will equal, and then 180 minus 75 is 105. So this angle right here is 105 degrees. So again, combined like terms, solved, it equals 180. So in this case, I had to subtract from 180. Moving on to the next. You can see the 3 here. You can't really see it on your paper, so I'm just calling it x. So the 3 angles add to 180, so x plus 50 plus 45 will equal 180 degrees. No, it doesn't matter which order you put these in when you're putting them plus, just the fact that you put them in order, because it doesn't matter which order we add in. I'm going to combine the 50 plus the 45, so x plus 95 will equal 180 degrees. And then, so that I can get x by itself, I'm going to subtract 95 from both sides. So that makes this 0 here, and I'm left with just x equals, and then 180 minus 95 is 85 degrees. And so this angle 3 is an 85 degrees. So those are the simple ones. And then here's another pretty simple one. The diagram shows a ladder against a wall, and the angle of that ladder makes with the ground. What is the value of x? So why are we putting this one in here? Well, because we have this lovely box, and that means that we have a right angle of 90 degrees. We cannot forget that right angle. If I just did this, that is wrong. No, no. It needs to be x plus 63 plus 90 equals 180. This is very important. We do not want to leave that 90 out. From here, I'm just going to combine like terms. So x plus, and then 63 plus 90 is 153 equals 180. I'm going to subtract 153 from both sides. So then x will equal, and then 180 minus 153 is 27. So that's what would go in there. And that is our value of x. Again, we cannot forget the 90 degrees. Now, there is a shortcut with this one. Because 90 is half of 180, these other 2 angles have to add to 90. So if you watch the 63 plus 27, 6 and 7 is 10, 6 plus 2 is 8, carry that 1 from the other 10, and when you've got 90. So 63 plus 27 is 90. These 2 angles will always add to 90. So you can easily set it up like we've been setting it up, or if you remember the fact that a right angle is half of 180 degrees, then you can just work with, we could have just done 90 minus 63 and got our 27. Either way, we get the same answer, so there's no right or wrong way to do the right angle problems. There are just a few of you that will recognize and remember that there is only 90 degrees left for the other two acute angles. All right. So then we may also have harder algebraic problems, and it's not may, you will also have harder algebraic problems. Now, you've got to keep in mind what it's asking for. We want the angles of the triangle J, K, and L, but in order to do that, I have to find X first. So in order to find X, I'm going to take each angle. So 2X, oops, not plus, 2X minus 14 plus X minus 2 plus 3X plus 10, the three inside angles add up to 180 degrees. From here we combine like terms, so x's with x's, 2x plus 1x is 3x plus 3x is 6x, so we have 6x. And then negative 14 minus 2, that's a negative 16. And negative 16 plus 10 is a negative 6, so minus 6 equals 180 degrees. From here, it's a two-step equation, so I'm going to add 6 to both sides. And then 6x equals 186. Divide both sides by 6, and x will equal 31. Now, again, we're not wanting what x equals, we're wanting each angle. So from here, we've got to plug back in. So I would plug in angle J would equal 2 times 31 minus 14. And 2 times 31 is 62 minus 14 equals 48 degrees. So angle J equals 48 degrees. Let's see, over here we'll do angle, I guess there should be an M there. No. Measure of angle J, measure of angle K will equal 3 times 31 plus 10. And 3 times 31 is 93. Yes. Plus 10. I second guessed myself there. And 93 plus 10 is 103 degrees. And then from here, we're going to do the measure of angle L, which is 31 minus 2, which equals 29 degrees. And if you ever are not sure if you did this right, take 48 plus 29 plus 103, and they should equal 180 degrees. If they don't, then there's something off somewhere. I would start by double checking when you found your angles. But that is it. Again, three inside angles add up to equal 180 degrees. And the hardest the problem gets is what we just did right here in this last example 4. You've got this. I believe in you. Until next time.